So we are working on 10.5, okay, probabilities of things called independent and dependent events. These are always when we're working on two things, okay? So the probability of one thing happening and then another thing happening, okay? So first thing we need to know are a couple of definitions. Technically, an independent event is when the result, okay, the result of one event is not affected, okay, is not affected by the result of another. Okay, the result of one event is not affected, not changed by another. Okay, conversely, a dependent event is when the result of one event is affected by the result of another. So, do we have any track athletes in here? Track or swimming, okay? This could be track or swimming. Think about it this way, okay? An independent event is basically like if you were a track athlete, okay? Do the results of the boys 100 meter, is that independent or dependent on the results of the girls 100 meter? Are they affected by each other? No. Okay, the result of one race isn't affected by the other one because they don't have anything in common. Okay, one is running girls, one is running boys. Okay, totally different. Those are independent events. However, a relay race, okay, like the 4x100, are those affected? Is the end result affected by the first person that runs in that relay? Yes, that is a dependent event. Okay, so the outcomes are affected by one another. The formulas for independent and dependent events are essentially the same. Okay, so the probability of A and B for an independent event is equal to probability of A. If we see the word and, does that mean multiply or add? Multiply. So probability of A multiplied by the probability of B. It is virtually the same for dependent event. Still probability of A and B is equal to the probability of the first thing happening multiplied by the probability of B after A has occurred. So it's dependent because one thing still has to happen. Okay, so one thing has to happen before the other one. They're still both multiply, not too big of a difference. So first thing we're going to talk about are some paper clips. Okay, say I do have paper clips actually. I have a little, jar that has paper clips in them. And I'm going to pull out a paper clip. Find the probability, so P. Before we do this, let's be thinking, what are my answers going to look like if I'm asking for probabilities? Are they going to be big numbers or are they fractions? Fractions. Anything with probability is going to be a fraction or a decimal, right? Or a percent. Generally, they're going to be in fractions, though. So probability of picking a red paper clip and then a blue one. So we're going to find the probability of red multiplied by the probability of blue. And this says with replacement. So what's the probability of first picking a red paper clip? How many total reds are there? 3 out of how many total? Add them together. You can use a calculator if you have to. 3 out of 12. Now, if I replace it, how many blues are there? There's still 5 blues, right? But if I replace it, how many total are there? I took the red one out. I put it back. So how many total paper clips are in my little bucket right now? Still 12. So is this independent or dependent of one another? Independent, because I put it back. Okay, if I didn't put it back, the amount that was in there would change. So that would be dependent. So this is independent. Okay, then you just have to multiply these together. You can cross-reduce at the beginning or at the end. It does not matter to me, right? As long as your answer is reduced. I would reduce at the beginning because that's generally a little bit easier. So 3 out of 12 reduces to 1 in 4. Multiply across the top, multiply across the bottom. You should end up with 5 over 48, okay? Whether or not you reduce at the beginning or at the end does not matter. Your overall answer should be 5 out of 48. Questions on how I got that? Okay, second one, exact same thing, but this time without replacement. So I take out the red one and I don't put it back. Okay, I need to use both paper clips, for instance. So again, probability of red multiplied by probability of blue. So what's the probability of first picking a red paper clip? 3 out of 12. Okay, there's 3 in there, 12 total. Multiplied by, if I don't put it back, how many blue ones are in my box? 5 out of how many total? 11. Okay, if I didn't put it back, there are less to choose from. So this is dependent. Okay, so it's not really that you have to know a different formula, you just have to think about it. Okay, if I took out a paper clip and did not replace it, there's less to choose from. You're still going to multiply across, still going to reduce at the end. Okay, I'm going to reduce at the beginning because I think it's easier. You don't have to. Multiply the numerators together, it gives you 5. Multiply the denominators, 4 times 11 is 44. That is fully reduced. That's your answer. So first thing we're dealing with is just independent and dependent events. You're just multiplying things together. Questions on how I did that? Not too bad, hopefully. Next thing we're going to talk about is using something called a tree diagram. Okay, this is called a tree diagram. We're going to use these. Okay, I made you copies of these so you don't have to write down these long word problems. Okay, do not worry about the word problems on your homework. You don't have to write down all the words. You do need to write down tree diagrams probably though. So it says a flight is sold out. All passengers arrive and board the plane. No empty seats. Okay, the seats in the plane are 15% business class, which is just a fancy way of saying first class, and 85% economy, which is just coach, basically. So people get on the plane. You are going to draw in this tree diagram. They either go to business or economy class. Okay, business class or economy class. So first class or their coach. Of the passengers, 70% have carry-on luggage. Okay, so this is luggage, carry-on luggage, and 30% do not. Okay, this is either you do or you don't. There's nothing in between. 30% did not carry on luggage. Now, you also have to fill in the economy tree, okay, the economy branch. So again, they either have luggage or they do not. You could just write no. Now what you have to fill in are the percentages, okay, but we need to convert the percentages into decimals. So business class is 15%. How do I write 15% as a decimal? 0.15. So we're going to label this branch 0.15. Economy is how much percent? 85%. So 85% as a decimal, 0.85. Notice that each branch together equals 1. Okay? They're either business or economy, 100%. These have to add up to 1. Okay? Same thing on these little branches. Luggage was 70%, so I'm going to write that as 0.7. If you need to write 0.70, that is fine, but it's the exact same thing. Even if they didn't tell you the other 30%, you could figure out that if 70% did have luggage, 30% or 0.3 did not. Okay, and you have to fill that in for each branch. So again, 0.7 and 0.3. Now, once you've filled that in, that's the difficult part. Now, all you really have to do is just follow the branch. Okay, we want to find the probability that a passenger selected at random, so they pick one person off the plane, will be sitting in business class and will not have carry-on luggage. So I would take either a highlighter or I would circle the branches. Business class, follow that one. No luggage, not have carry-on luggage, follow that one. Literally, you multiply the two percentages together. Okay, so probability of business multiplied by probability of no luggage is equal to, and you're going to multiply. So probability of being in business class is 0.15. Probability of no luggage is 0.3. Multiply those together. What is 0.15 times 0.3? No. 0.15 times 0.3. You need to go back to 4th or 5th grade when you learned how to multiply decimals. Multiply things together and count up the number of decimal places. How many decimal places should this answer have? 3 of them. You multiply this together, this is 0.045, not 0.45, okay? If you're only looking at 15% of the people and then 30% of that, it makes no sense that you would have 45 as an answer. 15% of the total people, 30% of those people, doesn't make sense that you'd get a bigger number. Okay, so make sure when you're dealing with these that you're thinking the common sense on the decimals. Okay, now since your questions started in percentages, I want you to end in percentages. So how would you write this as a percent? 4.5%. Okay, I would probably take either answer, but you should finish your question or finish your answer like the question started, and this one was in percents. You don't know how to switch to percentages, you just move it over 2 decimal places. Questions on how I did that. So this is following a tree diagram. I would recommend a highlighter or just circling the branches, multiplying them together. Questions? Pretty good? Okay, on the back. Do any of you guys, obviously you're at school normally when this is happening, but has anyone ever seen The Price is Right? Like you stay homesick for a day, you feel like being, you know, I don't know, mildly entertained, you want to watch something with your grandma, I don't know, whatever. Okay? And there, people go on The Price is Right and they love to win a new car. Okay, so we're on The Price is Right, we're going to pretend, and we're going to say, you have just won a new car. You are super excited. Okay, feel the excitement. I can feel it from you, really. It's either a Mustang or a Prius. Yay!
Wait,
okay.
what model of Mustang?
I don't know. So you know because you watch The Price is Right a lot, and you're really into these cars and you really want to win one. Okay, you just know 30% of all Mustangs have automatic transmission. 90% of all Priuses built have automatic transmission. Is this true? I have no idea. I made it up. Okay, but just go with it. We need to fill in this tree chart. So you get on The Price is Right. What are your 2 options if you're going to win a car? What's your first branch go to?
Mustang.
Mustang or Prius. So Mustang or Prius. Then from a Mustang, what are your 2 options for transmission? Automatic, or if you don't have automatic transmission, you have stick. It's called manual. Okay? Stick or automatic. Okay? Same thing on a Prius. It's either going to be automatic or manual transmission. There is no other options. Okay? So it's all the cars are either a Mustang or a Prius. It's either automatic or manual. Now let's fill in what we know. So of all the Mustangs, so just this branch here, 30% have automatic transmission. So fill this in as 0.3. If 30% have automatic transmission, what percent has manual? 0.7. These have to add up to equal a whole 1. Okay, so it has to be 100% of the cars. Now, you do not automatically copy these onto the next branch because this is different. Okay, it's saying 90% of all Priuses have automatic. So 0.9 automatic Priuses. Therefore, how many have manual? 0.1 or 10%. They didn't tell you this part though, but they did tell you something over here. Okay, we're saying if there is a 0.675 chance that your car is a Prius, so you followed this line, with automatic transmission. If you multiplied those together, so basically the probability of winning a Prius multiplied by the probability of having automatic transmission is equal to 0.675. Fill in what you do know. Do you know the probability of winning a Prius? Do I know that from my chart? No, so leave it as X. Okay? Multiplied by what's the probability of getting an automatic transmission Prius? 0.9. Is equal to 0.675. Now, can you solve for the probability of getting a Prius? And how? X times 0.9 equals 0.675. Divide. Okay? Divide both sides by 0.9. Yes, you can use calculators if you absolutely need to on this test. Okay, not that big of a deal. So if we're going to go backwards, you're going to find the probability of winning a Prius. If you take that backwards, 0.675 divided by 0.9, it's equal to 0.75. Now, what did my question ask you, though? So you can go backwards and say the Prius was 0.75. So you have a 75% of winning a Prius. What's my question asking, though? What's the probability you won a Mustang? So how do you find that? You have one part of the branch. What does the whole thing have to equal? 1. So if 75% of people win Priuses, how many would win a Mustang? 25. Okay, so 0.25. So you have to do some addition here. Okay, you can figure that out. So the probability of winning a Mustang is 25%. If you just write 0.25, that's fine, or you could write 25%. Questions on how I did that? So that's the second type of problem you're going to see today. Okay, last thing we're going to go over is something called conditional probability. Okay, so I'm going to give you a definition and then a formula. So conditional probability is the influence of one event on another. Okay, the influence of one event on another. A lot of times this is talking about jobs. Okay, so the influence of having a high school diploma or having a college degree based on if you get a job. So the formula for conditional probability is the probability of event B given event A. Okay, that's how we write it out in words, excuse me. You're going to see this written as probability of B/A. We say that as given. Okay, so this is said as probability of B given A is equal to the probability of both A and B happening divided by the probability of A. This is a complicated formula, but I'm going to show you how to break it down and make it simpler. Okay, but just know that's the actual technical formula. This will be in your notes quiz for sure. So you're going to get word problems like this. You're going to need to make, or if it's not already there, you're going to need to draw in your own chart like this. Okay, so for number 5, it says, at a business, 7 men employed are college graduates and 12 women employed are college graduates. Would you agree that being a college graduate could affect your employment?
Yes.
Yes. Okay, so that's why this is called conditional probability, the influence of being a college graduate based on you getting a job. There are 2 men who did not graduate college and 3 women who did not graduate. We want to find the probability that if you randomly pick an employee, sorry, I shouldn't say and, it will be a female given that you picked a college graduate. So we need to fill in this chart basically. Okay, so we know the people employed there are either men or women. Okay, they are either a college graduate, so you need to fill in the labels there first, or not college grads. A lot of times you're going to see the chart that's just like this and doesn't have the sides. You need to add in the sides, and these are going to be your totals. Okay, so we're going to have to add in those sides if they're not there already. So tell me, how many men are college graduates? Jalen. Male college graduates, how many do I have? 7 men are college graduates. How many women are college graduates? 12. So plug this in. How many men are not college graduates? 2. And how many women are not college graduates? 3. Now, you need to fill in the totals. So how many total men are there? We're going to add 7 and 2 together. That gives you a 9 total for the men. Women, there's 12 graduates, 3 that didn't, 15 total. Then you also have to, so we did our vertical total, or excuse me, our horizontal totals, the side-to-side ones. You also have to do the up and down totals. So how many total college graduates do they have? 19. How many total non-college graduates, Spencer? 5. Then, whether you add Vertically or horizontally, how many total employees do they have? 24. Okay, so this number added together this way or side to side, you're going to end up with 24. We don't add all these together and get 48. That does not work. So we want to know what's the probability that if you randomly pick a person, it will be a female given you picked a college graduate. The way we do that is finding the probability of being both divided by, it's always the first one. And the way I want you to kind of look at this is think about, if I'm going to pick someone that's both, look at this given as if I only pick from, so in this case, am I only picking from the females or the graduates? No, you're finding someone that's both a female and a graduate, but I'm only looking out of what? The graduates. So, how many people are both female and college graduates? 12 women college graduates. So pull that out of your chart. Out of how many total people are graduates? 19. So you have to look at this total, okay? So a lot of this stuff is not necessary. So you are only picking from the college graduates. So the actual answer here is 12 over 19. That's your answer, okay? These can be a little tricky, okay? Make sure you use these notes when you're doing your homework, And your homework for this, so there's going to be 2 parts, okay? The first part is worksheet 5 that's in your packet. You're working on numbers 1 through 9, but skip number 8. Okay, you're also skipping number 10 technically, but I didn't assign it to you. As well as worksheet 5B. You do not have worksheet 5B, so you need to pick it up. I will give it to you. And you're only doing numbers 1 through 4. Okay, 5B is going to be a lot of these charts. Okay, you also have a quiz today. So what you're going to do